Is that the one that's just like symbols?
It's a whole bunch of symbols, yeah. I like wingdings the best. Okay, probably looks like math, like calculus, you know. I'm just writing wingdings up here for you. All right, so the derivative and the tangent line problem. So here's what we're trying to do. Now, we're just going to start by drawing a picture, okay? We have, and this picture is going to get kind of ugly, so don't draw it little. Okay, so we're going to have lots of stuff on this picture. So what we have here is a XY axis, and what I'm going to put on this function I had a really nice picture. There's my picture. Okay. I'm going to put, this is my x-axis, this is my y-axis, and I'm going to draw a very general function here. This is what my function looks like. It's pretty. It's called f of x. And it could be g of x, or I don't know, it could be any old function. This is any old function. All right? Now, here's what I want to do in calculus. In calculus, I want to find out information about this curve. Okay? Calculus is an invented math. Okay? Calculus was invented, okay, made up. All right? It was a made up math because we had limitations on the algebra that was going to help us out. Thank you. Espen, this is for you. All right, so there were limitations. And here's what mathematicians long ago, did you know they had like math clubs that got together? Like these were grown men, and instead of getting together and playing COD, they got together and did math. Imagine that. That sounds like so much fun. This was ancient Greece. They also wore togas and ate a lot of grapes.
Every day?
Yes, every day. Maybe they were fermented grapes. I'm not sure. Anyways.
That's us.
That's you?
You're speaking us.
Okay.
Make us drink now?
Okay. So they thought, well, all right, here's what I want to do. You know how you can find the slope of a line? They're like, hey, what if I wanted to find the slope of that curve right there? Why would you want to? Well, because slope is actually like rate of change, or how fast something is moving. So what if you wanted to find how fast, if there's a bug crawling on this line, if you wanted to find out exactly how fast that bug was moving right there, how could you find it? That has to do with the slope right there, okay? Or the slope right there. That's the question that mathematicians wanted to be able to answer. And they realized that the slope of this curve at that point was different than the slope of, say, this curve at this point. Okay, or the slope of this curve at this point, way up here. I mean, think about trying to like run up this thing. Okay, what happens? I mean, does it get harder or easier? Harder. Okay, so like it starts out kind of easy, so like a low number would represent the slope here, and then it'd be a little bit bigger number would represent the slope here, and what kind of number would represent that slope? Like a really big number, it would be like hard. Like how many of you have seen this show, Ultimate Ninja Warrior?
Oh my God.
Like, isn't that like the thing at the very end?
Yeah.
Yeah, that's like what you're trying to do right here. Okay.
No, I'm talking about the part where they've got the bar and they like have to pull themselves up, take it out, and get it in their next.
Oh, I would like be dead. I'd be on the ground.
You know which one I'm
Yeah, I
talking
do.
about?
Yeah.
Oh,
I bet you. Kelsey could do it. Let's sponsor Kelsey to be an Ultimate Ninja Warrior. Okay, sorry. This is way. She is a gymnast. She could just jump.
No, she can't jump. She'd have to do some sort of flip.
Like a back?
They don't just jump. They do all these weird things and eventually they get higher and higher and higher. So that's what she'd have to do.
Okay. All right, so what's the problem with trying to find the slope right there? Or right there? What did we have to have back in Algebra 1? Let's say I had a line like this. What did I need in order to find the slope of the line?
Or a point.
1 point? I needed 2 points. Okay, what's the slope formula? It's rise over run. Okay, what's the formula if I have two ordered pairs? y2 minus y1 over x2 minus x1, right? That's how I find the slope. But the key is, how many points do I need to find the slope? I need 2 points. If I'm trying to find the slope right there, do I have 2 points? No. Well, you could say, well, yeah, I do. I have this point and this point. But the line that connects these two has a different slope than right there or even right there. So I don't have 2 points. Okay, so here's what I want you to realize. If I really wanted to find the slope at that 1 point, wouldn't I need to know the slope of the line tangent right there? Okay, oh my gosh, tangent, that's a big word. Oh, I gotta remember geometry now.
Just don't say anything.
What's geometry? Tangent. Tangent is what?
A line that touches a circle.
Okay, a line that touches a circle at 1 point. Okay, that's good. Very good. So we don't have a circle, so what's the tangent line here?
Oh.
Ooh, yeah.
That's
What, Taylor? Okay, so how many times does the tangent line hit this curve?
1.
1. And what point are we interested in?
That one.
That one right there. So I want to find, if I can find the slope of that line, I'm drawing it really light right now. If I can find the slope of that line right there, wouldn't I know the slope of the curve at that point? All right, so tell me, what do I need to find the slope? I need 2 points. How many do I have?
1.
I have 1. Okay. I can make another one. How? Make one up? Put it on the line. I don't know the equation of that line. I don't know anything about that line. I know it goes through that 1 point. Tell me what.
Just put a circle on the line.
There might be, but my graph probably, as usual, my graphs aren't perfect. Are yours?
Well, mine's near it.
Okay, Mac's are perfect, so Mac wouldn't need to learn any of this garbage. He can just put another dot on. Okay. All right. Well, here's what we do. We actually don't find the slope of that right away. And so here's what I'm going to do. I'm going to develop for you. This is kind of like a why the formula you wrote down from page 97 works. Okay? Now, the formula on page 97, it said the definition of the tangent line with slope m. Okay? So this is the tangent line right here that we're trying to define. Okay? And we're trying to find its slope, right? Isn't that what we want to do? Because that would be the slope of the curve right there at that point that I'm actually interested in. So slopes of curves, that's one of the big questions of calculus, has to do with tangent lines. All right, so here's the way we develop that. And I'm just going to walk through this kind of fast. I'll post a slideshow of the pictures a little bit later with all the definitions. All right, so I know that I need 2 points to find a slope. So what I'm going to do is here's my point that I'm interested in, and the x value that goes with this is called C. I can't name a specific point because otherwise I'm not doing a proof. This y value, this point right here, is named by the ordered pair C, comma, f of C. That should make sense because if my x value is C, there's the x value of the ordered pair. To get the y value, I put this x value into my function, and then I have f of C. All right? So there's my 1 point. I'm going to make up another point. And that other point is going to be this point way over here. But the point is I can find the value of that other point, right? We don't know anything more about this tangent line than that point right there. But since I have this whole curve, why not pick another point right on the curve? So that point, now, I'm not going to call this like another value. What I'm going to do is I'm going to take the C value that I started with, and I'm going to add delta x to it. Delta is a Greek letter meaning change. Delta means change in. So I'm changing the x value. Again, this is a proof, so I can't use numbers at all. So that's delta x. All right. There's also a picture of what I'm doing to start with on page 97. And there's several series of pictures. I'm not going to draw the nice series like they do. I'm just going to make this one really messy. All right, so this x value is what then? If I take C and add delta x to it, what is the name of this x value? C plus delta x. All right. So then what is the name of this ordered pair?
C
Plus delta x, comma, f of C plus delta x. Now doesn't that looks complicated, right? Is it really that complicated? Is it that big of a deal?
Nope.
It's not that big of a deal, okay? It's not that complicated. All right, so now, I now have this secant line. This is called a secant line. Oh, what's a secant line? Crosses a circle twice in 2 places, so notice how it crosses the function in 2 places. Yep. Now, can I find the slope of the secant line? Can I find the slope of the secant line?
Yeah.
All right, so I'm going to do that right now. So the slope of the secant line is going to be m equals, okay, what are the y, isn't it y minus y? Yeah, so what's the y value of that, the second point? F of C plus delta x, okay, and the y value of the first point, okay, minus f of C. So I'm just subtracting the y values. And then on the bottom, what do? I subtract the x value. So the x value of the second point is C plus delta x minus C. And what cancels? The C's. So then on the bottom, I just have delta x. Now, does that look anything like part of the formula you wrote down from page 97? So what is that formula really? Let's simplify. That formula minus the limit is just what formula from algebra? It's the slope formula. It's the slope formula. That's all it is. Did you know that all of calculus, one type of calculus, one branch is based on the slope? Everything we do about what's called derivatives is based on the slope. All right, so now, you know what? We still have not answered the question. We still have not answered the question at all. Because now I know the slope of that line, which obviously, is the slope of this line anywhere near the slope of that line? No, they're not even close. So this was kind of dumb. I guess we're wrong. What? You don't think you're wrong?
Not in the slightest bit.
We might need that for something else? Okay, yeah, we do actually. Because did I have to pick this point? Did I have to pick that point as my other point? Okay, could I have picked this point right here? Okay, and then could I have found the slope between this point and this point? Okay, and hold on, here's the key. The key is what I'm going to be doing right down here, so pay attention. So where did this point... No, well, it's not quite C plus delta x, but it's C plus something less than delta x, right?
Why?
Okay, we're not going to make up more letters. I'm tired. These letters are enough. Okay, I think we're done. But the point is, didn't I move the x value closer to the actual starting x value? Okay, now tell me about this slope. Is this a little bit better estimate of that slope? It's still pretty bad though, isn't it? Yeah, still really bad. Okay,